And in younger grades, I think it's grade 9. I used to teach grade 9. I think Tessellations is in grade 9. But, so that it's the same idea where you repeat a shape and you just keep going. Did I have my iPad going on when I taught this on the video? Was the iPad ever showing up on the screen? No? Okay. I may do so tomorrow if I review it. Okay. So the idea is for tiling questions, right, tessellations, is that the interior angles of your shapes that you're considering need to have a sum of exactly 360. So I asked you, regular triangles, could you tessellate? And if it's regular, there's 60 degrees in all corners, but we kind of focus on one corner. And if you think about it, right, there's 60 degrees all around. So a quick way to check this, if it's just one shape, I just go 360. I divide it by the interior angle of a triangle, which is 60. You divide it, and if you get an exact whole number, you know you can tessellate, right? Like this will actually work. I need 6 every time to continue this. If I could clone this right now, I could keep doing this, right? Stack them like that and continue that pattern indefinitely. Would always work out, okay? Obviously, once you get to the corners, you'd have to like cut it out and whatnot, but that's for another day, okay? Pentagons, on the other hand, it involves, right, if you figure out the interior angle of a pentagon, we figure out that it's 108. So 108 here, 108 there, 108 there. You're like, what shape goes in there? Like, you still need to fill that gap that remains, okay? So this doesn't work. And one way to check very quickly, this is the visual, right? If you divide that, you get 3 point something, right? 3.33, something like that. So it's not an exact number, okay? Not exact, therefore does not tessellate. You can also say you cannot use this to tile this particular floor. Okay, so I need you to understand that this is one method if it's just one shape, but you can also just take 360 and start taking off an interior angle one at a time. Okay, if you keep doing that, you end up with, let's just do this here real quick. That's 320. So 324 minus 360, you end up with 36 left. Okay? So that little thing is 36 degrees. Oh, yeah, you can't do that, right? 36 doesn't work. Page 49. Okay? So it doesn't work. And so most of the questions are going to ask you, can you use these shapes, right? And in this particular case, when you have different shapes, okay, exclamation mark, just a few, right? Oh, you can't see that, my bad. When there are different shapes, don't use this method. You gotta use at least one of each, okay? Once you've exhausted all your options, so you know, for example, the interior angle of, what is this? This is a hexagon, right? So the interior angle of a 6-sided shape is 120. The interior angle of a triangle is 60. Of a square, of a 4-sided, if you do that, is 90. Okay, so you kind of, the first order of business is figure out the interior angles. Mr. Dirksen, do I need to show the work for this? I'm okay if you don't show the work, like especially if it's the basic ones that, like for example, a triangle and a square, we know those. It's 90, right? It's 90 here. And I provided you with this visual because there's a 90 here, a 60, this is 120, and another 90. That adds up to 360 degrees, okay? But this is how you would show it mathematically, because I wouldn't expect you to draw this out, right? It would be too much work. So you just take off one at a time. 120, that's your hexagon. 60, that's your triangle. and then you take off the 90, that's the square, right? That's what I would do. So you subtract one of each, and then you get 90 left over, okay? That's left over that you still need to find a shape for to fill. And then you just grab the one that works in this case. So I would take off another square, okay? This is another square until you get to 0 degrees. Okay, that's when you know you can use a combination of these shapes to make this tiling pattern, okay? So you can, so it says, can you use this? You would say yes, okay? Using 2 squares. If I ask you for the combo, you'd have to say using 2 squares, a triangle, and a hexagon will work or will tessellate or something like that. You make a final statement where you're saying, in this case, I had to use 2 squares, a hexagon, and a triangle. But you must use one of each to start you off. Like, that's why I did that right away. I saw what was left over and then see what works, okay? See what combination you still need. And I did D and D. Did I do D on the video? I did use, okay. It doesn't work. I don't think it works. Triangle is 60, square is 90, octagon is 135. So if you go 360 minus 60 minus 90 minus 135, that's 360 minus 120 minus 135, that's 105 left. There's nothing, right, in this mix, there's nothing that could work out here. If you took off 90, you'd be left with 45. You don't have a shape that has an interior angle of 45. It wouldn't work. Right? You can't take off another 135 because 135 is bigger than what's left, right? So this one doesn't work. Using 2 60s, 60 and 60 would be 120, doesn't work, okay? So in this case, does not work. And I would consider this as showing your work, like finding out the interior angles, stating them, then showing how you're subtracting. Don't forget your degrees, right? Does not work, that is fine. Okay? If it works, please tell me the combo that you've used, okay? I think I want to just do that last one on page 50 so you know how to do one of those. A regular floor tiler designs custom floors using tiles in the shape of regular polygons. So, by the way, we're always going to be under the assumption that we're dealing with regular shapes, right? Otherwise, we don't know that all the interior angles are the same. So we're using 3 different shapes, right? 3 shapes. There's a square, a hexagon, and what is the 3rd shape? That is what is asking here. We know that the square has an interior angle of 90 degrees. We know that a hexagon, well, if you don't know, use the formula, right? Hexagon is how many sides? 6 sides, right? N is 6. So if you forget, like if you're like, you know what, that day off really threw me off, you would use this formula. Okay? So you just go 6 minus 2 times 180 over 6. That would be 6 minus 2 is 4, right? 4 times 180 over 6. That would be 720 over 6, which gives you the 120 degrees that you're after, right? So the interior angle of a hexagon, you can just do like, go like that, or hex, whatever you want to do, is 120. So we know that the interior angles of the first 2 shapes are given. So I go 360 minus 120 minus 60, and I will figure out how much is left over. 300, that'd be 180 left over. No, I'm wrong here. Hold on one second. So this would be 240. Am I off? Square, hexagon. So 150, right? Or did I make a mistake on my key? It's 180. Ah, oh, you need the sheets. I know the mistake. Yeah. I see my mistake. It is 90, 60, close enough. It's close enough. I just can't be a pilot or anything like that, right? Because then I would probably crash the plane. But there you go. It's 90, not 60, because we're dealing with squares, right? So that's 150. There you go. So that's left, right? I took out the hexagon. That's the shape I must use. I take out the square, okay? I must use, so I'm left with 150. And you can try, like if you took away another 90, you're left with 60. And what is 60? Do we have a shape that has an interior angle of 60? Triangle. So you can probably argue that the third shape could be a triangle, right? Because you could take away a 90 and whatnot. But there, you can also try, is there 150? Is there a shape with an interior angle of 150? So you figure that out. What's the exterior angle? If the interior is 150, then the exterior angle at that point is 30, right? Because remember, exterior and interior always add up to 180. And so then I use this formula, right? Exterior angle is 360 over n. Put the 1 there, cross multiply and divide. So that's 360 divided by 30, okay? And then you get 12 sides. Therefore, third shape is a dodecagon. I didn't ask you to name it, so if you just said the third shape is a 12-sided polygon, that's fine, okay? But I don't know if I want to have the extra, I will just say, if interior angle is 150, then, right, it turns out that the exterior angle is 30 of that polygon we're trying to figure out. So the third shape is a dodecagon. So a triangle would have worked as well. So you just have to kind of be creative there, but it had to be a third shape that you had to introduce. Okay. I think we are good at this point. I would like you to, for now we're going to pause here.